Hi everyone, today I will share with you what is ultrasonic sensor and how to do it. Let's get started. Today I will introduce the HCSR04 ultrasonic sensor, and this sensor uses sonar to determine the distance to an object. As you can see in the screen, this is the ultrasonic sensor and this is the object. And this sensor reads from 2 cm to 400 cm with an accuracy of 0.3 cm. And in essence, this particular module comes with ultrasonic transmitter and receiver module. As it is a figure of the ultrasonic sensor, there are two parts of the ultrasonic sensor. This is the transmitter part, and it is a receiver. And it is the actual ultrasonic sensor you can see, and we will connect to the Arduino to measure the distance from the ultrasonic sensor and object. Next tonight, I will talk about the ultrasonic sensor pinout, and this figure shows the ultrasonic sensor pinout. There are 4 pins in the HCSR04 sensor. I will talk about from left to right. The first pin is the VCC, and the last pin is ZND. VCC and ZND pin is the power supply of the sensor. You can connect 5 volts and ZND volt from Arduino. The next pin is trigger pin. The trigger pin is trigger of the signal, and echo pin is receive the signal from trigger pin. When signal from trigger pin come from trigger pin to the object, and after that the echo pin is receive the signal from object to ultrasonic sensor. Now we can connect trigger pin and echo pin to the digital pin of Arduino. Next, we are talk about the wiring from Arduino and ultrasonic sensor. As you can see in the screen, the VCC pin and ZND pin is connected to the power. VCC pin is connected to the 5 volt of Arduino, and ZND pin is connected to the ZND pin of Arduino for power supply. Next, the trigger pin I will connect to the pin 11 of the Arduino, and the echo pin I will connect to the pin 12 to receive the signal from the object. This is very easy to wiring, and I also summarize the wiring pin to in the table. Next, I will talk about the distance calculation methods. As you can see in screen, there are 2 parts. The first part is the transmission signal, and the second part is the receive signal from the object. And the distance formula is the distance equal speed multiply time and divide 2. Why we need to divide 2? Because the signal come from sensor to object and return from object to sensor. So we are double distance. So we need divide 2. It's very easy to understand. And now we talk about the parameter. And as you can see, the speed equal. This is the speed of sound. So now speed of sound is 343 meter per second, and it's also equal 34.5 centimeter per second. And in the Arduino code, I will use in microseconds. So it is 0.03 3, 4, 3. I will talk later. Next, I will talk about the Arduino function. In Arduino code, I will use the per-in function, and it is a formula per-in, and the first parameter is the pin of the Arduino, and I will use the trigger pin. I will use the echo pin, and the second parameter is the value. And the pin is the number of the Arduino pin on which you want to read the bus. I will read the bus in echo pin. The second parameter is the value. Value is the type of the bus you read, either high or low. It's very easy to understand. And this function reads the bus either high or low on the pin. For example, if value is high, per-in wait for the pin to go from low to high, and that's timing, then wait for the pin to go low and stop timing. And result is returns the length of the per-in microseconds. It is very important. It return in microsecond and give up and return 0 if no complete burst was received within the timeout. This function is easy to understand, and now we will code the Arduino code. Now let's make wiring circuit between Arduino and ultrasonic sensor. And I also use the Wokey.com environment for simulation. Firstly, select the ultrasonic sensor, click into the plus button, and press the ultrasonic sensor. Here, it is a RCHC SR04 ultrasonic distance sensor. Click to select, and I will place the sensor beside the Arduino. And now I will connect the power pin of the ultrasonic sensor. As you know, the power pin is a VCC and ZND. I will connect the VCC pin from ultrasonic sensor to the 5V of Arduino, and ZND from ultrasonic sensor to the ZND of Arduino, and I will classify the wiring. It's very hard to classify. It's okay. And now I will wiring the check pin and echo pin. Check pin I will connect to the pin 11 of Arduino. And echo pin I will connect to the pin 12 of Arduino. The check pin the echo pin I will change to the yellow pin, yellow Y. It's finished. And now I will change to the Arduino IDE. Firstly, I define some pin from ultrasonic sensor with the define function. Define trigger pin, trick pin with the 11 from Arduino, and define echo pin from 12 pin Arduino. And I also define the distance with distance by centimeter and distance by inch. I will call the long distance centimeter and distance inches. And I also use a duration variable. It's finished for define. And now in the voice setup, I will define the serial print serial dot begin. I will call power rate 9600 and in mode check pin. With check pin, I will cross output and also pin mode for echo pin. Echo pin is input. It's finished for voice setup function. A check pin, I will define check pin is output and echo pin is input. And echo pin is a receive signal and check pin is a transmit signal. In the void loop, I will write the function to calculate the distance from the sensor to the object. And now I will call digital write. Digital write, I send signal from check pin, and call low 0. And delay, I will delay microsecond. And delay microsecond, I will delay 2 microsecond. And next, I will turn on the trigger pin by digital write, trigger pin and high. And I also use a delay microsecond, and in this time I will delay 10 seconds or 10 microsecond. And after that, I will turn off the check pin by digital write, check pin low. And now I will calculate the duration. Duration equal per inch. I will use the per inch function. And now I will, the first parameter is echo pin, is a receive signal, and I will use a low signal. Yes. And now it's time to calculate the distance. I will call distance centimeter equal duration multiply 0.0343, and I will don't forget to divide 2. I also copy and paste for distance inches, and I will call multiply 0.0135 for inch, and there is finished for calculate the distance by centimeter and inch. And the next step is display in the serial monitor. So I will use the serial dot print. I will show the distance inch. It is inch, and I will use yes. And I copy and paste distance centimeter, and it is a centimeter. And after that, I will serial print. I will make a new line Yes, and after that, I will delay. I will delay for monitoring. I will delay 1 second. Yes, it's a finished. Very easy to understand. Now I will copy. I will verify. Because I have not that through the Arduino board. Through the Arduino Uno. Okay, and verify again. This is a duration equal pin no per in. I missed. Okay, it is okay, and I will download to the Arduino. It's finished. Now for simulation, I will copy the code. Copy all the codes and paste to the wokey.com. And after that, click Run button. And you will see the 0 pin. Maybe there is an error. I will check again. Firstly, 3 pin and echo pin. After that, I will call the long distance centimeter, distance x, and duration. Pin mode, trigger pin output, and pin mode echo pin input is okay. Now I will digitalize trigger pin low. Delay microsecond. 2 microsecond, and digitalize trigger pin high. And delay microsecond. 10 microsecond. And after that, digitalize a trigger pin low. After that, next we use a calculate the duration and distance. Duration equal per in echo pin, and I think this is a problem because it is high. And now I will run again. Yes, it's working. Now distance is about 400 centimeter. 400 centimeter is okay. Now it's 189 centimeter is okay. It's good. It's very good. Now I will change to the 99 centimeter. It's okay. It's okay. Now our code is working. And thank you so much for watching, and see you in the next video. Thank you so much.